Hello everyone, myself Krishna Prasades, Assistant Professor, Department of Mechanical Engineering, MIT Mysore. Welcome to the lecture session on Module 2, Pumps and Actuators. In the previous class, our beloved colleague Professor Sachin has explained about what is meant by the pump, pumping theory and the detailed classification of the pump. So, before moving on to the next part, it is called positive displacement pump. Again we need to understand, so what is meant by the pump? So, pump, it is nothing but it is a heart of the hydraulic system which converts mechanical energy into the hydraulic energy. And here the mechanical energy required to operate the pump, it is supplied with the help of the prime movers like electrical motor. And due to the mechanical action of the pump, a vacuum is going to created at the suction line of the pump, and this will permit atmospheric pressure to force the fluid into the suction line of the pump. So, once the fluid enters into the suction line of the pump, and the pumping elements are then transfer the fluid into the hydraulic system. So, this is regarding to the pump. Then what is meant by the classification of them? So, the two basic classification of the pump, it is nothing but the positive displacement pump, other one it is called non-positive displacement pump. In case of the positive displacement pump, there is a fixed amount of fluid is transferred into the hydraulic system. So, that is called it as the positive displacement pump. So, and very much important in case of the positive displacement pump, it is mainly used to obtain the very high pressure and low volume application. Okay, so maximum pressure we can achieve in case of the positive displacement pump, it is around 10,000 psi to 20,000 psi. So, this is regarding to the positive displacement pump. Second one, it is called non-positive displacement pump, it is also called it as the hydrodynamic pump. So, in case of the hydrodynamic pump, it is mainly used for low pressure and high volume application, and the maximum pressure we can achieve it is around 250 to 500 psi pressure we can be achieved. So, this is regarding to the non-positive displacement pump. So, example of the non-positive displacement pump, it is nothing but centrifugal pump, and the main example in case of the positive displacement pump, it is called as the reciprocating pump as well as the rotary pump. So, based on the motion of the internal elements in case of the pump, it is categorized into three types. Okay, so positive displacement pump itself, it is categorized into three types. So, first one, it is called as the gear pump. So, in the gear pump, it is classified into four parts, that is called external gear pump, internal gear pump, lobe pump and gerotor pump. Then the second part, it is called as the vane pump. So, in the vane pump, again it is two types. The one, it is called unbalanced vane pump. So, in the unbalanced vane pump, again it is categorized based on the displacement, that is called fixed and variable displacement. Then in the second part, it is called balanced vane pump, that is called as the fixed displacement. Then it is called as the piston pump. The piston pump, it is called axial design and the radial design. So, this is regarding to the classification of positive displacement pump. Okay, so already told what is meant by the positive displacement pump. So, positive displacement pump, it is nothing but here it consists of a fixed amount of fluid is ejected into the hydraulic system. So, that is main thing, it is in case of the positive displacement pump. And also in case of the positive displacement pump, there is a positive internal seal against the leakage of the fluid during when it is flow from suction side to the discharge side of the pump. So, this is regarding to the positive displacement pump. So, in case of the positive displacement pump, first we need to understand the construction and working of the external gear pump. Okay. So, just observe the figure. In case of the external gear pump, it consists of the two gears, and each gear it is driven with the help of the driven shaft as well as the driver shaft. Okay. So, next, what is mean by the external gear pump? In case of the external gear pump, the fluid flow occurs between the teeth of two meshing gears. So, this is the gear 1 and this is the gear 2. Okay. So, external gear pump, here flow occurs between the teeth of two meshing gears. So, this is called as the external gear pump. Here, in case of the external gear pump, it consists of the two gears, and each gear it is connected to the shaft, and these gears, it may be the helical gear or the spur gear. Okay, and whichever the gear it is connected to the prime movers like electrical motor, and that gear it will become driving shaft, and the another one it will become the driven shaft. And two ports are provided as an inlet port as well as the discharge port, and it will be provided around the housing of the external gear pump. Okay, then this complete construction it is used to transfer the liquid from one place to the another place with the help of the fixed amount of liquid. And as well as here fluid flow occurs between the meshing gears, then space between the gear and the pump housing. Okay. So, this is regarding to the construction of the external gear pump. So, then what is the working of the external gear pump? One of the shaft is connected to the prime mover, and the prime mover is connected to the electrical motor, and this shaft it will become the driving shaft. So when this driving shaft rotate, it meshes with the second gear and this will become the driven shaft. Then what happens when the two shafts are meshing together? So when two shafts are meshing together, suction side is going to create. So how the suction side is going to create? In the suction side is going to occur when teeth are going out of mesh. Okay, so this is called it as the suction side. In the suction side, when teeth are go into out of mesh, here the volume is going to increases. So due to the increase in volume, so pressure is going to reduces and reduction in pressure is always less than the atmospheric pressure. Okay, when the pressure is below the atmospheric pressure occurs in the pump housing, then this connected to the oil supply or reservoir. Okay, then this suction side it is connected to the oil supply or the reservoir, then the atmospheric pressure causes the fluid is pushes into this void. Okay, because this oil pressure is kept at the atmospheric pressure. So this is regarding to the suction side. Okay, when teeth are going to mesh, here when teeth are going to mesh, this is called discharge side. In the discharge side, teeth are go into mesh, therefore here pressure is going to increases and volume is going to decrease. Therefore due to the increase in pressure, so the fluid is going to forced into the discharge port of the external gear pump. So this is regarding to the external gear pump. Okay, and the maximum pressure we can achieve in case of the external gear pump around 10 to 12,000 psi pressure can be achieved in case of the external gear pump. Okay, I repeat, what is the working of the external gear pump? Observe here. So external gear pump, it mainly consists of 2 gears and each gear is connected to the 2 shafts, and here one of the gear is connected to the prime movers like electrical motor and it will be acts as the driving shaft, and when it is meshes with the second gear and it will become the driven gear or driven shaft. Okay, and here oil supply it occurs between the teeth of the meshing gear as well as the wear plates as well as the pump housing. Okay, then suction side is created when teeth are going to out of mesh. Okay, because of that here volume is going to increases and pressure is going to decreases below the atmospheric pressure. So the pressure below the atmospheric pressure occurs inside the suction side of the pump. Here oil supply from the reservoir is enters into the pump housing. Okay, because here oil supply or the reservoir is vented into the atmospheric pressure. Then teeth are go into the mesh, here discharge side is going to occur. Here the pressure is going to increases and volume is going to decreases. So this increase in pressure of the oil is then enters into the discharge port through the outlet. So this is regarding to the external gear pump. So then how to determine the volumetric displacement of the external gear pump? So volumetric displacement of the external gear pump can be found by with the help of the volume of the hollow cylinder. Just observe here one of the gear, it may be driving shaft or the driving gear or the driven gear. Okay, so what is mean by the D0 represents? The D0 represents the outer diameter of the gear teeth, and Di represents the inner diameter of the gear teeth, and L represents the length of the gear teeth. So that volumetric displacement Vd is given by pi by 4 into D0 square minus Di square into L. So this is regarding to the volumetric displacement. Okay, so then how to find out the theoretical flow rate? So theoretical flow rate, it is nothing but Vd into N. So here Vd it is nothing but volumetric displacement of the pump, and N it is called it as the RPM of the pump or speed of the pump. So this is called it as the theoretical flow rate. So theoretical flow rate, it is given by the unit meter cube per minute, because Vd is mean by meter cube per revolution and N is nothing but revolution per minute. So revolution cancel out, then Qt it is expressed in terms of meter cube per minute. Then last one, it is called volumetric efficiency of the external gear pump. Okay, so here volumetric efficiency of the external gear pump, it is represented by Qa by Qt. Observe here what is mean by the Qa. Qa is nothing but actual flow rate and Qt it is nothing but theoretical flow rate. So what happens for the actual flow rate? Observe here there is a clearance between meshing gear teeth as well as the pump housing. Because of that, some amount of fluid from the discharge side is going to collapse into the suction side. So here actual flow rate is always less than the theoretical flow rate. Okay, so here actual flow rate is always less than the theoretical flow rate, and the maximum efficiency we can achieve in case of the external gear pump, it is around 90%. This is regarding to the external gear pump. The next topic, it is called internal gear pump. So here the construction and operation of the internal gear pump is very much simple. Okay, the main parts of the internal gear pump, it is called inner gear, regular shaped spur gear and crescent shaped seal, as well as the external housing. So these are all called as the main parts of the internal gear pump. So observe here the internal gear is placed inside the regular spur gear with the help of the crescent shaped seal. Okay, and internal gear has a teeth which are protruded outwards, and the regular spur gear having the teeth which are protruded inwards, and these two gears are going to meshes with each other with the help of the crescent shaped seal. Okay, so next very important one, it's called here inner gear is key to the shaft. Okay, so next, as the power is applied to the inner gear, then due to the rotation of the inner gear as well as the regular spur gear, so fluid is going to draws from the reservoir. Okay, when the fluid is going to draws from the reservoir, then it is forced to flow on both the sides of the crescent shaped seal. So either side of the crescent shaped seal acts as the suction side as well as the discharge side. Okay, when this inner gear, it is going to meshes with the side opposite to the crescent shaped seal, then the pressure is going to increases, then highly pressurized fluids, then it is enters into the discharge port through the outlet port. So this is called it as the working of the internal gear pump. Okay, I repeat, so what are the main parts of the internal gear pump? The main parts of the internal gear pump, it is called inner gear, then regular spur gear, crescent shaped seal and the housing. Here inner gear is placed inside the regular spur gear with the help of the crescent shaped seal, and then here the inner gear has the teeth which protruded outwards and the regular spur gear has the teeth which are protruded inwards, and these two gears are going to meshes with each other with the help of the crescent shaped seal. Okay, when the power is applied to the inner gear, due to the rotation of the inner gear as well as the regular spur gear, here the fluid is drawn from the reservoir, then it is forced to flow on the either side of the crescent shaped seal. Okay, so then either side of the crescent shaped seal, now it is acts as this is the suction port and this acts as the discharge port. In the inner gear, it is meshes with the crescent shaped seal, so the pressure is going to increases, then highly pressurized fluid, then it is enters into the outlet port. So this is regarding to the internal gear pump. So next one, it is called as what is mean by the gear rotor pump. Observe here, so one of the common type of the internal gear pump or similar type of the internal gear pump, it is called as the gear rotor pump. Okay, the same here inner gear is placed inside the outer gear without the crescent shaped seal, then it is called as the gear rotor pump. So that is the difference between internal gear pump and the gear rotor pump. Here inner gear is placed inside the outer gear with the help of the crescent shaped seal. Here inner gear is placed inside the outer gear without the crescent shaped seal. Okay, so then very much important thing, it is called here the inner gear having one teeth lesser than the outer gear in case of the gear rotor pump. Okay, so then this inner gear, it is key to the shaft. Then the shaft is connected to the prime mover which is connected to the electrical motor, then which will go into rotates both the gears. Okay, so this is regarding to the construction of the gear rotor pump. Then power is supplied to the driving shaft. What happens when the power is supplied to the driving shaft? Then each tooth of the inner gear is constantly meshes with the outer gear. So here inner gear, it is nothing but the gear rotor element, and the outer gear, it is nothing but gear rotor. Okay, when the power is supplied to the inner gear, then each tooth of the inner gear is constantly meshes with the outer gear or gear rotor. Okay, so very much important thing it is called here inner gear having the one teeth lesser than the outer gear, or outer gear it is having the one teeth higher than the inner gear, therefore outer gear it is rotates at the lower speed. Okay. So during the first half, here the space between the rotating elements is gradually increases from smaller volume to the larger volume. So due to the increase in volume, the pressure is going to decreases. That means the decrease in pressure it is always less than the atmospheric pressure. Because of that, the fluid is going to draws from the reservoir, then it is passes through the space between the rotating element. Okay. So from the inlet port, it is enters into the space between the rotating element, and when the passes through the rotating element, teeth are going to mesh. Okay. So during the second half, for the rotation of the inner gear, so here the space between the rotating element is gradually going to decreases. So when the space between the rotating element is gradually decreases, then volume is going to decreases and the pressure is going to increases. Then so from the discharge port, highly pressurized fluid is goes into the hydraulic system. So this is called it as the gear rotor. Okay. So I repeat, what is the working of the gear rotor pump? So here the gear rotor pump, it is mainly consists of the inner gear which is placed inside the outer gear without the crescent shaped seal. Okay. So then here inner gear has the one teeth lesser than the outer gear, and the inner gear is key to the shaft, and the shaft is connected to the prime mover which is connected to the electrical motor. Okay. So then as the power is applied to the inner gear, then the space between the rotating element is going to increases during the first half of the rotation, so that the volume is going to increases. So due to the increase in volume, so fluid draws from the reservoir and then it is enters into the space between the rotating element. So further off of the rotation, then the space between the rotating element is going to decreases. That means volume is going to decreases and pressure is going to increases. Then highly pressurized fluid is then enters into the discharge port. So this is regarding to the gear rotor pump. So last one, in case of the gear pump, it is called it as the lobe pump. One of the most similar type of external gear pump, it is called it as the lobe pump. That means your lobe pumps are called it as the externally meshing gears or externally meshing lobes. So this is called it as the lobe pump. So but what is the difference between external gear pump and a lobe pump? So in case of the lobe pump, here both the lobes are connected to the driving shaft and they are driven externally, and that means there is no actual contact between the lobes. That is very much important in case of the lobe pump. Then what happens in case of the lobe pump? Similar to the working of external gear pump. So in the suction side, here as the volume is going to increases and the pressure is going to decreases. At the suction side, as the volume is going to increases and the pressure is going to decreases below the atmospheric pressure, then this suction side is connected to the oil reservoir. So because of the atmospheric pressure pushes the fluid from the oil reservoir into the suction side of the pump. Okay. When teeth are go into the mesh, here the volume is going to decreases and pressure is going to increases. Then highly pressurized fluid is enters into the outlet port. So then what is the advantage in case of the lobe pump? Metric displacement of the pump is going to increase as compared to other pumps, but here it is having the very lesser mating elements, hence there is a greater amount of pulsation is going to occur in case of the lobe pump. So this is regarding to the lobe pump. Okay. So very simple, in case of the lobe pump, here consists of the two lobes, and these two lobes are connected to the driving shaft and they are driven externally. And similar, so in the suction side, as the volume is going to increases and the pressure is going to decreases below the atmospheric pressure, then atmospheric pressure is causes the fluid to enter into the suction side. So when the teeth are go into the mesh, here the volume is going to decreases and pressure is going to increases. Then highly pressurized fluid is enters into the outlet port. So this is regarding to the lobe pump. So next we are moving on to the Vane pump. Okay. The next classification regarding to the positive displacement pump, it is called it as the Vane pump. So here the fluid can be flow from one place to another place with the help of the cam ring as well as the vanes. Okay. So this is regarding to the Vane pump. So the classification of the Vane pump, it is based on the balanced Vane pump and unbalanced Vane pump. So in the balanced Vane pump itself, it is having the fixed displacement as well as the variable displacement. Okay. So before we are going to the fixed displacement and the variable displacement, first we need to understand what is meant by the Vane pump. So the Vane pump, it is also known as the rotary pump. Here it operates on the principle of increasing and decreasing volume. So that means during the increase in volume, what happens? So during the increase in volume, the space between the rotor and the cam-ring is going to increases, which causes the vacuum. Hence, the fluid is going to transfer from the reservoir into the fluid chamber and it completely fills the void. Similarly, during the decrease in volume, which causes the fluid to force out of the chamber with the under pressure, so this is called it as the Vane pump. Okay, so Vane pump, it is nothing but it operates on the principle of increasing volume and decreasing volume. So increase in volume causes the fluid transfer from the reservoir through the inlet port and fills the void, and decrease in volume causes the fluid to move out of the chamber under the pressure, so that is called it as the decrease in volume. Then what are the construction of the Vane pump? So construction of the Vane pump, it is very much simple. Observe here, so this is called it as the rotor. Okay, this rotor contains the radial slots and this rotor is going to rotate inside the cam-ring. Then these slots of the rotor contains the vanes. These vanes are always contact with the cam-ring. That means here the vanes of the rotor slots are designed to always contact with the cam-ring, and here centrifugal force keeps the vane always contacts with the cam-ring during its rotation. So this is the main construction of the vane pump. So I will repeat. So in case of the vane pump, it mainly consists of the rotor, and the rotor consists of the slots, and the rotor is going to rotate inside the cam-ring. And each rotor slot contains the vane, and this vane is designed to always contact with the cam-ring. And here centrifugal force keeps the rotor always contact with the cam-ring with the help of the rotation. So then what is the working in case of the vane pump? So working of the vane pump is very much simple. So during the off of the rotation of the rotor shaft, what happens here? The volume is going to increases, or the space is going to increases between the rotor and the cam-ring. So due to the increase in volume, then fluid is going to transfer, or due to the increase in volume, the pressure is going to decreases. So due to the decrease in pressure, atmospheric pressure causes the fluid enters into the space between the rotor and the cam-ring. Okay, so this is called it as the suction process. So during the suction process, the fluid is going to enters into the system, and that fluid it completely fills the void. Next, during the second half of the revolution. So during the second half of the revolution, then the volume is going to decreases and the pressure is going to increases. So this is regarding to the discharge process. So during the discharge process, the fluid is going to out of the chamber. Okay, so fluid is moves into the out of the chamber, so then it is called as the discharge process. So vane pumps, it is nothing but positive displacement pump. So in the positive displacement pump, here fixed amount of fluid is going to transfer from one place to the another with a very high pressure. So this is regarding to the vane pump. So observe here, during the first half of the rotation of the shaft, so here the space between the rotor and the cam-ring is going to increases. Due to the increase in volume, the pressure is going to decreases, hence the fluid is going to transfer into the space between the rotor as well as the cam-ring through the inlet port. Okay, similarly during the another half of the revolution, so here volume is going to decreases. So due to the decrease in volume, this cam-ring pushes the vane back to their places, hence volume is going to decreases. So due to the decrease in volume, the pressure is going to increases. Then highly pressurized fluids is moves through the outlet port into the hydraulic system. So this is regarding to the vane pump. So then what is the volumetric displacement of the vane pump? So volumetric displacement, or a maximum volumetric displacement of the vane pump, it is given by pi by 4 into dc square minus dr square into L. Observe here, what is mean by the DC represents? So DC represents, it is nothing but the diameter of the cam-ring. And what is dr? So dr represents the diameter of the rotor, and L it is called as the width of the rotor. And then observe here very much important thing, it is called here axis of the rotor and the axis of the cam-ring, it is not equal, and there is an eccentricity is achieved. So this is very much important. So what is mean by the maximum eccentricity? So maximum eccentricity is nothing but dc minus dr by 2. So and dc minus dr is equal to 2 times of maximum eccentricity. Call it as equation number 2, and this is called it as equation number 1. So now I am proceeding equation number 1, volumetric displacement is equal to pi by 4 into dc minus dr, dc plus dr into L. We know that dc minus dr is equal to 2 times of maximum eccentricity, then maximum volumetric displacement is equal to pi by 4, 2 times of maximum eccentricity, then dc plus dr into L. So here maximum volumetric displacement is equal to pi by 2 times of dc plus dr into 2 times of maximum eccentricity into the L. So this is called as the volumetric displacement of the Vane pump. Okay, I repeat. So here what is meant by the DC represents? The DC represents the diameter of the camring and the DR represents the diameter of the rotor, and LD it is called as the width of the rotor, and VD represents the maximum volumetric displacement of the pump and maximum eccentricity. So here axis of the rotor and the camring is not equal, there is an eccentricity is achieved, and that is called as the E, and then maximum eccentricity is nothing but DC minus dr by 2. So here volumetric displacement, it is equal to pi by 4 dc minus dr into dc plus dr into L. Now substitute dc minus dr is equal to 2 times of maximum eccentricity, that is volumetric displacement is equal to pi by 2 times of dc plus dr into 2 times of maximum eccentricity. So this is regarding to the volumetric displacement of the Vane pump. Okay, the next type of the Vane pump, it is called as the pressure compensated Vane pump. So when we need to use the pressure compensated Vane pump, when the Vane pumps having the provision for mechanically varying the eccentricity, then it is called as the variable displacement pump. And this variable displacement pump or a pressure compensated pump, it is used those pumps having a provision for varying the eccentricity as well as protection against the excessive pressure buildup, then it is called as the pressure compensated pump. Okay, so observe here what are the main parts in case of the pressure compensated pump. Spring loaded piston or a pressure compensator. So this end wheel or a pressure compensator are used to change the eccentricity, as well as direction of flow through the pump can be also varied with the help of the moving the camring with the help of the spring loaded piston or a pressure compensator by moving at the either side of the center from the camring. Okay, so this is regarding to the construction of the pressure compensated pump. So next observe what are the main parts available in the pressure compensated pump. So here the design what we have seen in case of the pressure compensated pump, it is very simple. That means here during the operation the entire hydraulic pressure it is acts on the camring with the help of the hydraulic piston, and that hydraulic piston is provided on the right side. But the hydraulic piston we cannot shown in the 2D diagram, and it is not visible in case of the 2D drawing. Okay, then because of the hydraulic force acting with the help of the piston, then this force the camring towards the left side. Okay, so then whenever the camring moves towards the left side, and this will force against the pressure compensator or the spring loaded piston which is provided on the left side. Okay, when the discharge pressure is very high, then this will going to pushes the pressure compensator and makes the eccentricity reduces. Okay, whenever the eccentricity is 0, then the discharge pressure will be maximum, or whenever the discharge pressure is 0, then the eccentricity will be maximum, or vice versa. Okay, whenever the discharge pressure is gradually increases from 0 to maximum, once it reaches the maximum, then eccentricity will be achieved 0. Once the eccentricity is achieved 0, then discharge pressure or the flow of the pump it will be going to decreases, or flow of the pump will be 0. So this is the way the Vane pump is going to protects their parts with the excessive pressure buildup. So this is called as the pressure compensated Vane pump. Okay, I repeat, in case of the pressure compensated Vane pump, so observe here their entire system pressure it acts on the camring with the help of the hydraulic piston provided on the right side, and this pushes the camring towards the left side, and it will going to force against the spring loaded piston or the pressure compensator provided on the left side. Whenever this hydraulic pressure or the discharge pressure exceeds the pressure compensator force, then it will go into shifts the eccentricity of the rotor as well as the camber. So when the eccentricity is maximum, discharge pressure will be 0. Okay, whenever the discharge pressure is gradually increases from 0 to maximum, then once it reaches the maximum value, then the eccentricity will be achieved 0, then flow become 0. So those are the pump, it will have the protection against the excessive pressure buildup. This is called as the pressure compensated vane pump. The last type of the vane pump, it is called as the balanced vane pump. So balanced vane pump is used in order to increase the life of the bearing. So in order to increase the life of the bearing, so balanced vane pumps are used. Okay, so balanced vane pump, it is one which consists of 2 inlet ports and 2 outlet ports which are diametrically opposite to each other. So therefore, as the pressure ports are provided diametrically opposite to each other, then the pressure is perfectly balanced. That means, observe here, so this is the one chamber from inlet to the outlet, and this is the another chamber, it is inlet to the outlet. So here the bearing loads from inlet to the outlet from this side to the bearing load to the inlet to the outlet from this side, both are going to nullify in case of the balanced vane pump. So because of the nullification, so perfect balance can be achieved in case of the balanced vane pump. And what is the main disadvantage in case of the balanced vane pump? So in case of the balanced vane pump, it cannot be used as a pressure compensated vane pump or cannot be used as a variable displacement pump, because here the axis of the rotor and axis of the cambering it almost the same. So that means there is no offset, there is no eccentricity, hence we cannot be used as a pressure compensated vane pumps, or it cannot be used as a variable displacement pump, hence it is also called as the fixed balance type of vane pump. Okay, so and very much important thing, it is called here, instead of the circular cambering, elliptical cambering can be used. Hence 2 separate pumping chamber is going to created on opposite sides of the housing. So this is regarding to the construction of the balanced vane pump. So then what is the working? So working of the balanced vane pump is also similar to the working of the general vane pump. So what happens here, it operates on the principle of increasing and decreasing volume. So during the one-off of the revolution of the rotor shaft, so here the volume is going to increases between the rotor as well as the vanes. So as the volume is going to increases, the pressure is going to decreases. So this acts as the suction process. So during the suction process, so the fluid from the reservoir is enters into the void and fills the void through the inlet port. So and during the discharge process, what happens? That means during the discharge process, due to the reduction in volume, so pressure is going to build because the cambering pushes the vane into this void and the excessive pressure will going to build up. This excessive pressure, it supplies the fixed amount of fluid through the outlet port into the hydraulic system. So this is regarding to the balanced vane pump. Okay, so balanced vane pump or vane pumps are having the higher pressure compared to the gear pump. So in this class finished with the what is meant by the gear pump and the types of the gear pump and what are the vane pumps and the type of the vane pumps. So in the vane pump there are 3 types. The one it is called pressure compensated vane pump, balanced vane pump and the fixed vane pump. Thank you.